Welcome. What we're going to do here is go through the assignment kinematic equations. I'm going to go through this step by step, problem by problem, explaining my thought process throughout the way. I would recommend that you at least attempt each problem before you watch the solution. Maybe you want to watch the solution to a couple questions first, and then go ahead and try on your own the next few, and then use this as a way to kind of check your work. This should be a tool that should help you guide your thinking when solving a kinematic equations problem. Kinematic equations are going to be with us throughout the rest of the year, so we really do need to get this down. Okay. Here is a list of the kinematic equation symbols. I do have to add one thing, just forgot to put in, is the line over the average velocity. So what we have here is just a quick review of the symbols, and I group them as such. We now have three separate velocities that we are going to now deal with. Instantaneous velocity, or your final velocity, initial velocity, or the starting velocity. You could say it's also the initial velocity. Whoops. And the average velocity, also known as v bar. The thing about average velocity is that average velocity can't be abbreviated in any other way. There's no other way to indicate an average velocity other than saying the words average velocity. Nevertheless, here are the three velocity symbols. And as velocity goes, all velocity has the same unit, which is meter per second. So if you're one of those people that likes to read the question, rather, they don't read the question, they just look for the units, and you see m/s and nothing else, there is no way to distinguish whether that meters per second is an instantaneous velocity, its initial velocity, or if it's an average velocity. You will have to read the words around it to know. So velocity is actually going to become the most challenging thing to differentiate. All velocity is measured in meters per second. Displacement, however, is a little bit more simple. It's always measured in meters. So if you ever see meters, it's going to be displacement or distance in some cases, but mostly displacement. A, of course, stands for acceleration. So if we remember m/s squared, that's going to be our acceleration. You see that unit, you know it's an acceleration. Just a reminder, just like before, these units are different. Do not confuse them. Watch out for them carefully. And time will, of course, be measured in seconds. All right? If at any point you want to pause this and copy it down, if you don't already have this down, feel free to do so. Because then there's also operative words. I told you that words can indicate what value you have. But what if you're just lacking a number altogether? It is entirely possible that you could just see the words from rest in a problem. And if you do, you must know that that means the v0, the initial velocity, is 0. If you see to a stop or comes to a stop or ends up stopped, now I want you guys to be able to think. I don't want you to just be locked into, oh, I don't see the word to a stop, so there's no way that the final velocity could be 0. If it says an object ends up stopped, I don't want you to get so locked into this concrete way of thinking that it says, oh, well, it didn't say to a stop. This is just kind of a way that sometimes you can go ahead and read words to find these values. If you happen to see constant velocity, now this one's a little bit trickier because this one should ring some bells when we get into definitions of what acceleration actually is. Acceleration is defined as the change in velocity. So if you are at a constant velocity, it means your acceleration is 0. Because if you are at a constant velocity, your velocity is not changing. In other words, the velocity changes 0 meters per second per second. So if you ever see the words constant velocity, know that they've given you information in that problem. And by no means are these an exhaustive list, these aren't always necessarily exactly true, but again, I need you to think, and I need you to think holistically. When we see V0, you're talking about things in the past tense. Words like before, started off, was. I want you to think about it. Words that indicate a V or a final velocity or an instantaneous velocity would be words like then or after, ended up. But again, these aren't the only words. So I need you to just take a step back and try to visualize each situation as it happens. So we're going to go through every single question on the assignment, kinematic equations. Question by question, problem by problem, walking you through the entire way. So, okay. Our 4 kinematic equations are on the side of the screen. Equations 1, 2, 3, and 4. And I will always keep the order the same. I will never switch that out. It is always going to be in that order. So if I say equation 2, I'm always going to be referring to d equals v naught t plus 1/2 at squared. Now, what does this question say? Okay, let's not forget the strategies that we had. How far? Stop. What are we looking for? We're looking for distance. So we are going to make a list of variables like we have up until now. How far did a biker go who accelerated from rest? Plus 5 meters per second squared. Plus 5 meters per second squared. When I see plus 5 meters per second squared, bells should be going off in my head, because when I see meters per second squared, I need to know that that is an acceleration. For 6 seconds, 6 seconds is the time. Six seconds is the time. Okay, I feel like I'm missing something. Well, you are. When I see from rest, that's going to give me a value just in word form. When I see from rest, I need to know that that means that the initial velocity is 0, or the V0 is 0 meters per second. We're almost always going to have 4 variables in our list. The only exception to that would be when you're dealing with equation 4. Equation 4 is kind of the odd man out here. It's the only one that has v bar, the average velocity, and it only has 3 variables. If you look, all the other equations have 4 separate variables. So more times than not, we're not going to use equation 4. It's really going to be kind of the odd equation in the bunch. But regardless if it's the odd equation or not, the strategy for picking equations is always going to be the same. I have a list of variables here. The equation that I'm going to use has to match this list of variables perfectly. Okay, this is where people get a little confused. So when I say perfectly, okay, d equals question mark. I'm looking for a distance because it says how far. Could I use equation 1? Well, equation 1 has a v, v0, a, and d, t. Question 1 doesn't even have the variable distance in it. As a result, I know that I can't solve for distance if distance isn't in the equation. I cannot use equation 1 to solve for the distance. Oh, well, Bizzuto, it's got to be equation 2 because that solves for distance. Okay, it could be, but it also could be equation 3 because both of these equations have a distance. And we know it's not equation 4 because there's no distance. So just from the bat, these two words right here, how far, automatically eliminate equations 1 and 4. Well, let's keep going. Let's keep going. A, all right, let's look at equation 2. A, do I have an A in it? I do, yeah, it's right there. Okay, so far so good. T, I have a T. I have 2 T's. That's okay. It's the same variable. V naught. I do have a V naught. Oh, nice. It matches it perfectly. Okay, well, Pizzuto, could I have used equation 3 anyway? It had a V naught and it had an A, but be careful. Equation 3 had a V. I do not have a V in my list. I do not have a V in my list. As a result, I can't use that equation. It doesn't match perfectly. I also have a time, and there's no time in this equation. So however you want to think about it, you just need to make sure that your list of variables matches perfectly. Equation 2 is going to be the one that we're going to use. Now, it's actually fairly easy. Now, it's just a matter of plugging and chugging into the equation. It's just algebra from here. We actually did all the physics. I'm just going to plug in. D equals 0 times t. 0 times anything is 0. 1/2, 5, 6 squared. All right. 0 times anything is 0, so that's gone. Half of 5 is 2.5. 6 squared is 36. I am going through this math quickly. If you ever need to pause and just take a minute, do that. 90. Perfect. You make your list of variables, you compare it to the equations, you pick, you plug in, and you solve. How fast? Excellent. How fast? Because we're dealing with accelerations, we know we're talking about a velocity. Okay, we're talking about a velocity, talking about a velocity, talking about a velocity. Which velocity? Yeah, I don't know yet. Because it could be initial, could be final, instantaneous, or it could be average. Don't know yet. How fast did a condor end up flying? If it was moving plus 21 meters per second over a distance of 115 meters, it accelerated negative 1.5 meters per second squared. Ah, okay. Good stuff here. How fast did a condor end up flying? If it was moving. Ends up tends to indicate a final velocity. We're looking for v in this question, final velocity. If it was moving plus 21, that is going to be the v naught. Over a distance of 115 meters, and accelerated negative 1.5 meters per second squared. All right, awesome. This is how you are supposed to identify your variables and make a list. You can mark up the questions, highlight them, cross them out, do what you need to do to make them make sense. All right, look at this. We got a list of 4 variables. What equation are we going to use? I don't know yet. So this is the process. Make your list of variables. Be confident in your list of variables. And start cross-checking. I have a velocity. So this is what I do. I just go through them in order. I always start with 1. All right, I have a velocity. 1 has a velocity. I have a v naught. 1 has a v naught. I have a d. Oh no. I have a distance. There's no distance in this equation. In fact, this equation has a time, and I don't have a time. Can't be the first equation. All right, let's try again. Let's go to the next one. Could it be? All right, I have a velocity. There's no velocity in this equation. Can't solve for it if it's not in it. Doesn't match perfectly. Also, this equation has a t. I don't have a t, so I couldn't use that anyway. 2 reasons. Okay, all right, let's keep going. This one has a v, v naught, v naught, a, d. Perfect match. Perfect match. This is the equation that we're going to use. We're not going to use a 4. It doesn't mention average velocity anywhere. Now, I want to make sure that we understand how this equation works. We have not done enough work with this equation. So just a quick little reminder. These squareds are just part of the equation. Unfortunately, I'm not going to be able to show you this year where they come from. If you take calculus and college-based physics, you might get to see. But this year, I'm going to just ask you to just trust me that they're there. And I'm sorry, it's never a fun answer to say just trust me, but they're there. Which means if we will have to square or square root these values depending where they are in the equation. What do you mean by that? Okay, let me show you. V squared equals V naught squared plus 2AD. All right. Okay, let's plug into this, John. V squared equals 21 squared plus 2 negative 1.5 115. Just plugged in. This 2, sorry. I almost forgot to mention. Thank you. Yes. This 2, like the half, is just a number that's always there. It's just something we have to accept. Not a fun answer, I know, but it is what it is. V squared equals 21 squared, I believe, is 441, if I remember correctly. It is 441 plus, I'm just going to multiply these 3 numbers. 2 times negative 1.5 times 115, just multiply straight across, is negative 345. All right, good. When I add these 2 numbers up, I get V squared equals 96. But I'm not done, because I don't want V squared, I want V. So I've got to square root both sides, and when I square root both sides, I get 9.79, it goes on, let's just say, I know, 9.79 meters per second. Because it really shouldn't be 9.80, yeah, it probably should, it's fine, it's fine. You get here, this is what I care about. Nice. A bus was driving down the highway. Was driving. Let me highlight that. Was driving. After 8 seconds, was driving and after. I hope we're getting to the point where we feel comfortable calling this V naught and this V and this T. I hope we're comfortable with that too. It says what is the acceleration, so there we go. Let's make our list. A equals question mark, okay? V naught equals negative 32, all right? T equals 8, and V equals negative 28. Okay, so there's some units on there. Oh, one thing about units. You may have noticed that I don't put units. I don't put units in the math. They get messy, they get confusing. I don't recommend it. I don't think you should put your units in the algebra, in the math. All right, let's break it down. Let's break it down. All right, what equation? I have an A. Okay, I have an A here. That's fine. V naught, T, V. Oh, that was easy. Equation 1 has all 4 variables. Wait a minute, Bizzuto. Can we just look at the other equations? Can we just see? Because maybe 2 equations have them all. They don't. But maybe they do. Let's just find out. Equation 2 has a distance. There's no distance in our list. Bam. Same thing with 3. Bam. 4, in addition to not having an average velocity, there's no a to solve for. Bam. Bam. It's got to be equation 1. The more you do this, the more comfortable you should be with this. V equals V naught plus AT. So I'm just going to plug in, and I'm just going to solve. Negative 28, excuse me, equals negative 32 plus AT. All right, I want to get the A by itself. I'm going to add 32, add 32, both sides, gone. Positive 4 equals 8a. Divide by 8, 1/2, or 0.5 meters per second squared equals a. Nice. If a cat is trotting plus 3 meters per second, all right, not really sure which one that is yet. It's a velocity, I do know that. After 5 seconds, ends up moving. Ends up moving. Well, ends up moving is going to be the v. Ends up is clearly the v, which means that this plus 3, by process of elimination, would have to be v naught. Another thing is the word after here kind of indicates that as well. And it says, what was its average velocity? Oh, nice. Let's make our list of variables. We have v naught is 3. All right. Time is 5. V is 19. M/S, M/S, and V bar equals question mark. I hope that we are comfortable with the fact that because we have a V bar and there's only one equation that's V bar, I hope we know that it's not going to be any of these. If ever there's average velocity, there's only one option of what to do. But I'm going to let you guys know, I threw a curveball in here. Intentionally so. I'm sure I'm going to catch some of you with it too. This is always a 2. When I plug it into this equation, if the V is 19 plus the V naught is 3, some people would have a gut feeling to go ahead and make the denominator a 5 because that's the time. Time is irrelevant in this equation. It doesn't matter. It's extra information. Don't worry about it. You don't need it. It's just to throw you off. There is always a 2 at the bottom of this equation. This was unnecessary. You didn't need it. How long? Stop. What are you looking for? Time. Okay, actually, you know what? Can I eliminate any equations? Can I just know that I'm looking for time? Okay, I guess. Well, there's a time in the first equation, so it could be that one. There's a time in the second equation, so it could be that one. Oh, geez. There's no time here, and there's no time here. So just because I read the first 2 words of the question, I've already eliminated half of the possible equations. How long does it take a bird that is flying 4 meters per second to end up going 10 meters per second with an acceleration of 4 meters per second squared? Well, if this says ends up going, that's clearly my final velocity. I can use process of elimination or deduction to realize that well, if this is the final velocity, then this has got to be the initial velocity. And the acceleration is 4. Awesome. 2 equations to pick from. Is it number 1 or number 2? Well, hopefully you guys are noticing some patterns, and I hope that you're saying it to the screen as you watch this, but I hope you realize it is going to be number 1. The variables match up perfectly. And there's no distance, so we can't use that one anyway. Okay, v equals v naught plus a t. 10 equals 4 plus 4 t. Minus 4 minus 4, 6 equals 4 t. 1.5 is the time. Nice. Let's really read this one. If a ball was rolling down a hill, a distance of 120 meters to the right. All right, okay. So we got the distance is positive, that right, okay, just with an acceleration of 5, okay. So far, so good. This isn't too bad. Uh-oh, it hits the bottom 2 seconds later. Oh no. How fast was it rolling before it got to the hill? How fast was it rolling before it got to the hill? So we're looking for velocity, but we have 3 options. It can be initial, instantaneous, or average. Those are for 3 velocities. It says how fast was it rolling before it got to the hill? Before indicates a beginning. Yes. We are looking for V naught. We are looking for V naught here. I'm not asking how fast it was rolling after it got to the bottom of the hill. I want to know how fast it was going before it hit the hill, before it accelerated. Let's match up our variables. Okay. Distance. Don't have a distance. Can't be equation 1. What about equation 2? Distance, okay. V naught, T is twice, okay, A. Matches perfectly. Can't be equation 3 because I have a T and there's no T in it. It definitely can't be this one because, well, there's no average velocity. Now, I want to ask you guys something. For those of you who thought it was V, you'll hit a problem. No equation has those 4 variables. So if you ever have these 4 variables, something has gone awry. Notice that. No equation has those 4 variables. So we are looking for V naught using equation 2. D equals V naught T plus 1/2 AT squared. Let's do this. 120 equals V naught times 2 plus 1/2 5 2 squared. 120 equals 2 V naught plus half of 5 is 2.5. 2 squared is in fact 4. Again, I'm just flying through this math now because I know that you can stop, pause, and look at it as you need. 2.5 times 4 is 10, minus 10 from both sides, minus 10 from both sides. 110 equals 2v0. So we're going to divide both sides by 2. And we're going to get, our answer is 55 meters per second is v0. Nice. How far? Looking for distance. Would a llama go? If it started off walking, geez, that's definitely got to be an initial velocity. Started off has to be a starting velocity, plus 2 meters per second. And it accelerated 3 meters per second while ending, meters per second squared, excuse me, while ending up moving. And all the key phrases are here. Yes. Yes, what is the only equation that has it? Let's cross-check. D, V0, V0. Oh, time. Time is the issue. We have no time. There's no time. It's got to be equation 3 because we crossed them all out. Let's just double-check. V, A, V0, V0, D, D. Done. V squared equals V0 squared plus 2AD. 10 squared equals 2 squared plus 2 times 3 times D. 100 equals 4 plus 6D minus 4 minus 4, 96 equals 6D. Divide both sides by 6, and you get, yeah, I don't know why I had to type that in. I actually completely knew that. 16 meters is the distance. Hopefully you can see it's getting easier. How long? Looking for time. Time equals question mark. I hope that you start to understand why I'm able to do that. Those two words allow me to cross off any equation that doesn't have a t in it. To end up covering how long does it take for a jogger to end up covering 256 meters? That's a distance, of course. Of course. Of course. If he accelerated plus 4 meters per second squared. Oh, but that's it. That's all I got. That's all she wrote. Is it? Is it, though? We haven't seen one of these in a while. Those operative words do exist. And you can't ever forget that your V0 would be 0 when it's from rest. So that means I have a choice. Could it be equation 1? T, I got T. The distance. I don't have a distance in equation 1, but I have a distance in my list. Doesn't match. Doesn't match. Can't use it. Done. This is the only equation that has all the variables. 256 equals 0t plus 1/2 4t squared. Now, 0 times anything is 0. So this just cancels out. Students tend not to want to cancel out a variable, but even a variable times 0 is 0. So please know that if ever that's 0, the whole thing goes away. 1/2 of 4 is 2t squared. To get the t by itself, you have to divide both sides by 2, which is going to be 128 equals t squared. I'm going to square root that junk. 11.31 is the time. How fast? Is the train moving? Okay. Don't know. I don't know. That's a velocity. I don't know which one yet. If it covers, 350 meters. I know what that is. That's clearly a distance. And 45 seconds. Okay. So far, so good. With a constant velocity. I feel like constant velocity is one of those operative phrases that I should have written down back earlier, and it is. If ever you see a constant velocity, A equals 0. Now, if the acceleration equals 0, this is important. We haven't done a problem like this yet. If the acceleration is 0, all the v's are the same. If the acceleration is the 0, your initial velocity would equal your final velocity because your velocity is not changing. That's what 0 acceleration means. That's what a constant velocity means. Your velocity is constant, so they're all the same. So in this case, what is the only equation that has d, t, and a? All right, there's no d here. There's no t here. Oh, if I use this equation to solve for v naught, that is the speed of the train because the speed is constant, the velocity is constant. I'm looking for v naught in this equation because it's the same thing as v. Interesting. In fact, if ever you see constant velocity, I'll just give you a little hint here. Equation 2 is pretty much the only way to go. If ever you see constant velocity, equation 2 is the only way to go. 350 equals v naught times 45. And just like in the other problem, if the a is 0, all the other things just go away. 0 times anything is 0. So I just have 350 equals v naught times 45. So what I'm going to do is I'm going to divide both sides by 45. That's it. Get 7.7 repeating. Thoughts, problems, questions, concerns? Let's go. How far? Should be getting good at that by now. How far did a car go that was driving 30 meters per second down the highway and accelerated 2 meters per second squared for 4 seconds? Was driving down the highway, and then, then this is kind of the after part, which means that this is the before part, so this is the v naught. A is 2, t is 4. That's a square, not a 3. Okay. 2 equations to pick from, 1 equation to use. We don't have a v, And we have a t. D equals 30 times 4 plus 1/2 2 4 squared. 120 plus 1 times 16. D equals 136. Nice. Imagine you roll a ball down a hill. Okay, so ball's going down a hill. You roll it with an initial velocity. Well, that was easy. It just gave me a freaking initial velocity. This is going to be easy. And rolls down a distance of 120 meters in 2 seconds. Down. Don't forget, down means a negative direction. That's something that people will definitely forget. What is the acceleration the ball experiences? So we're looking for the A. All right, we haven't done this too much. Okay. Okay, we're looking for acceleration. All right, cross that out. Let's do it up. V. No V. Can't be this one. Let's see. All right. D V naught T A T. Awesome. It's got to be that one. It's a good equation. D equals V naught T plus 1/2 AT squared. This one's going to be done more for the math. I think people will mess up the math in this equation a bit more. But all I'm doing is just plugging the numbers in. And I just have to do order of operations. Negative 120 equals negative 40 plus 1/2 A times 4. Half of 4 is 2A. And just bring the rest down. Add 40 to both sides. And what you're left with is negative 80 equals 2A. Divide both sides by 2. Sorry. And then you get your answer of negative 40 is your acceleration. Done. So if we look at this one and it says how long, that's time, I already know I can eliminate these two. Let's look for patterns because there are no time. The variable time is not in equation 3 or 4. All right, how long will it take little Susie to go? 18 meters, okay, distance equals 18 meters. Okay, if she walks 4 meters per second, I don't know what that is. If I see the term constant velocity, I know that that means the acceleration is 0. And I said it would be when the acceleration is 0, equation 2 is the equation to use. Well, let's just think about it logically, though. Because if acceleration is 0, that means this goes away. And then you know V equals V naught. We already knew that. So we don't need to know that again. We're not going to use this equation. So that means the 4 meters per second is the V naught. Sorry. And we're looking for the time. Easy. D equals V naught T plus 1/2 AT squared. 18 equals 4t plus 1/2. This is 0. It doesn't matter what the rest is. It doesn't because it all goes away. I'm just going to divide both sides by 4. 4.5 seconds is the time. Nice. Okay, well, so here's the thing. Here's the thing about something like this. In this question, we really have 6 variables. In a question like this, we're going to solve for all of them. Okay, what are you talking about, Pizzuto? A bowling ball was rolled. All right, let's really label this. It was rolled plus 6. Was rolled. Comes to a stop 18 seconds. I have a T. I have a was rolled is going to be a V naught. And of course, comes to a stop is an operative phrase, which means the V is 0. So I have all these variables. Okay, they're going to be in my little list. V naught equals 6, V is 0, and T equals 18. All right, so it says, what is the average velocity? Well, V bar, there's only one V bar equation. V plus V naught over 2. We can solve for that, no problem. 6 plus 0 over 2. I hope you can agree that the V bar is 3 meters per second. Okay. Now it says what was the acceleration. So now I have a couple of options. I want to solve for the acceleration. So I am going to use acceleration, and I have 3 variables here I can use to go with it. If I look at my equations, equation 1 is really the only viable option. Equation 1 is the only one that has a V naught, V, T, and A. Remember, you can't use V bar in any of the other equations, so we have to use equation 1. So what does that look like? Well, V equals V naught plus AT. 0 equals 6 plus A times 18 minus 6 minus 6. Negative 6 equals 18A. Divide by 18. You get negative 1/3 or negative 0.3 repeating. 3 repeating meters per second squared. Okay. So now we have 5 variables in our list. So the last thing is to look for how far. I want you to know now there are actually multiple correct ways to solve for the answer. I actually have enough variables to use either equation 2 or 3, depending on your preference. You want to know, it doesn't matter which equation you use, you will get the same answer. And I trust that some of you are going to check me on this if you are particularly motivated. But regardless of the equation that you use, you should get, I'm going to use equation 2, 6 times 18, I'm just out of space and I don't know where to write it. 6 times 18 plus 1/2 times negative 0.33 times 18 squared. So I got about 50, using this equation, I got about 54.54. 54.54 is the distance using this equation. And when I use this equation, you probably want to see that, don't you? Just 6 times 18 plus 1/2 times 0.33 negative 18 squared. This one sure. I'm looking for the space. 0 squared equals 6 squared plus 2 negative 0.33 d. 36 plus negative 0.66 d equals 0. Minus 36 from both sides, and then divide by negative 0.66, and I get the exact same answer. It doesn't matter which way you do, you will get the same answer. Nice. So the same thing applies in this problem. You are going to be given 3 pieces of information. I only see 2 numbers. Oh, reading. I have an A equals 6, D equals 10, V equals 0. So it says, what is the initial velocity? So I'm looking for V naught. What is the only equation that I can use? I'm going to start with equation 3. This is the only one I can use for now. Uh, 0 squared equals V naught squared plus 2 times negative 6 times negative 10. All right, perfect. 0 equals V naught squared plus negative 120. Add 120 to both sides and square root that. The square root of 120 is, of course, 10.95. So 120 equals V naught squared, and we've got to square root that. So V naught equals 10.95. So ultimately, I just threw another variable in my list. Now I can use that 10.95 in all the other equations to solve for the V bar and the T. I hope we feel comfortable doing V bar now. It's actually not going to be too bad. 0 plus 10.95. That's why you had to solve for that first. So maybe, you might have to jump around in a question like this. Maybe, don't forget it's over 2. Maybe you just don't know exactly how what the order is going to be, but trust your variables, trust the equations. So divide that by 2. Yeah, you get like 5.475 or something like that. I don't know. 5.47. Whatever. I know you can round that, but let's just call it 5.47. I get it. Meters per second. And then how long? Now, with all these variables, let's pick. Let's just pick the first equation. Options. 0 equals 10.95 plus negative 6 t. T equals 1.825. Hopefully you can see this process gets faster the more you go through it. Have faith, trust in your abilities, and identify your variables.